like to welcome everybody. Thank you for joining our webinar today. My name is Carla Sanchez, and I'm the Director of Communications and Programs here at the HTA. And today we're going to be discussing the best technologies that can help solve your drayage issues. And without further ado, I'll hand it over to Dan Pimentel, the President at ESP Logistics Technology.
Hello, everybody. Wanted to thank everybody for being on this call today. We really appreciate it. And to give a little bit of my background, I'm Dan Pimentel. I'm president of ESP, a technology company that addresses issues within the supply chain. We're going to give you a lot more detail about thoughts of how technology can help make your business more efficient. My history is that I worked in retail and media and entertainment companies for most of my career. Walt Disney Company, Discovery Communications as examples. And most recently, I've worked for companies or involved in companies like TTSI that I'm sure you're aware of, and Tailored Services. So that's my background. I'm going to let the team come in and do their introductions, and then we'll get going. Cindy, we'll start with you.
Excellent. I hope everyone can hear me. I'm Cindy Elliott. I'm with Esri, ESRI in Redlands, California. We are a geospatial intelligence technology company. You'll hear a little bit more about the data and the technology throughout the course of today, but I lead the company's strategy and go-to-market for what we refer to as business industries, which includes logistics and distribution. Jack.
Hello, my name's Jack Levis. I'm retired from UPS after 43 years. I was initially responsible for operations, engineering, and planning at the beginning of my career. I planned the West Coast operation network. I eventually went into corporate, being responsible for technology for operators. In about the last 20 years of my career, my job was operations digitalization and transformation.
All right, Brian.
Hey everyone, Brian Smith here. I'm our Chief Product Officer at ESP. My history goes back 20 plus years, basically solving very complex challenges using location and technology. So it's been a fun journey and excited to be doing this in the supply chain space.
All right, thank you guys. And then getting a little bit of context as to, what we're talking about. Logistics, right? 2027, it's supposed to be a $13 trillion industry. That's an annual spend number. And when you think about it, that would be the third largest economy in the world if it was a country. And there's nothing on top of that that tries to, oversee the movement, the flow, the efficiency. It's a patchwork of thousands of companies with even thousands more systems and different types of data sets. That our guess would be that there's probably 1 to 2 trillion of an opportunity for efficiency in that system by using and applying technology. Efficiency opportunities, what does that translate into? With your existing assets, it translates into more capacity, the ability to do more with less. And that results in what we view as higher profits for companies that in a lot of cases have very thin margins. Now, when you look at the rest of the chart here, it's anticipated 80 billion will be spent on IoT solutions for logistics, and you have an amount for analytics. But there continues to be, in our opinion, an underinvestment in technology in logistics, right? Either one of those numbers are anywhere from 0.1 to 0.6% of the total annual spend on logistics. You'd hope that could be 10 to 15%. Because again, we think that you could drive in massive efficiencies into the system by applying technology. And I think most of you would agree that when you look at the bottom chart here, the factory to the shipping, cargo handling, trucking, warehousing, most of those inefficiencies happen in the handoff from one node to another, right? And why is it an efficient handoff? Because the systems don't talk to each other in a lot of cases. The truck might have to arrive in queue at the Port of LA and Long Beach and spend an hour and a half in queue and then 50 minutes in terminal looking for their chassis and container. We know with TTSI that there'd be days where only 1.5 containers could be pulled in an 8-hour shift per driver. That's a really inefficient pull, and in the end, they're driving maybe only 15 to 25 miles outside of the port. So again, most of what we focus on and what we want to talk about today is how do you get better handoff between the systems and the nodes of transportation to drive efficiency and profitability into these businesses. The reason we have Cindy here is that she's part of an organization that explores the science of GIS. Okay, and what is GIS? It's geographic information systems. But I think GIS, again, as a science, is key to unlocking a lot of the efficiencies I just talked about. The ability to get 15 to 20% more utilization of your assets by knowing where they are in time and space, and being able to then overlay the environmental impacts to a good handoff and the flow of goods through those environments. So that's pretty much mostly what I wanted to bring in on the front end. So we're going to talk about GIS. We're going to talk about various systems and applications that might help solve efficiencies. But also there's this big wave, everybody talks about machine learning and AI. And how will that impact the industry as it moves forward in the next 10 to 15 years? And I think what AI and machine learning is going to drive is this move from, in a lot of cases, human-centric decision making, dispatchers making decisions without complete information as to what the queues are at various terminals and what impacts it might have from geopolitical risk or weather patterns or traffic patterns. And then once you start collecting that data and applying machine learning, you're ultimately going to have a machine providing recommendations to that human, saying you're going to get much more efficiency if you move this way or that way. And ultimately, there's probably a future where you get a reliance, much like automated driving cars. At a certain point, they're testing them today, but at some point, they're going to be fully functional and driving for us. And we think that machine learning can get there in starting to prescribe what's going to happen and making decisions on behalf of the business. So I'm going to hand it over now to Cindy, because Cindy's part of that GIS world. They had a conference a couple months ago in San Diego, and you wouldn't believe that there'd be 18,000 people there. But they're a massive company that are doing amazing things in the world. So Cindy, I'll pass it off to you.
Excellent. Well, thanks. And thank you everyone for being here today. Dan's introduced us now to GIS, which is the Geographic Information System. Esri is one of multiple organizations that supply this technology and data across the globe. Everything occupies a location of the world at a point in time, whether it's stationary, a building, a depot, or a fleet or ship or a rail. And the more that organizations can understand that context of location, coupled with those predictive and kind of decision-making models that Dan talked about, the faster the decision-making can happen. I kind of say, have it at your fingertips, right? But then when you overlay context like weather, live traffic, maybe geopolitical incidents, anything of that nature, it really gives you kind of an operating model or a digital twin of the real world time and place, and helping organizations make those decisions. So I want to draw your attention to two things. First, on the right-hand side, you see that system, kind of that system that allows you to connect your network of assets. Again, stationary, natural, moving, all of your assets within your organization occupy and become a network. And it's actually a network that's in motion, right? We operate 7 days a week, 24 hours a day. Everything's censored, from the truck to the roads. Being able to collect data on all that, those assets and where they are in space and time, map it and visualize, apply analysis, that traffic, that crowd, that kind of disruption, wildfires, floods, whatever it might be, and now go into more of that modeling your decision-making approaches and then taking that action. So that right-hand side kind of sweeps this context of all that data that's coming together in your environment, using a GIS or a technology platform to kind of unify it. On the left side, we call this the layer or the hamburger approach, because it's allowing organizations to take data, incident feeds that we just talked about, real-time geopolitical, external data, weather, traffic, and internal data, And then ultimately that creates what we refer to as operations space map. But it allows organizations to seamlessly bring those layers together, whether it's where are people, where are incidents of little red dogs, where are the streets, where are your roadways, where are your shipping lanes, and continue to bring all that together so that you're seeing one, what we call pane of glass. So you could see here that what's, this concept of GIS is the ability to bring everything together in one, kind of global view and in real-time analysis. I'm going to share two quick case studies with you. I'm at Portwatch. They monitor now 98% of the globe's live shipping traffic through digital twin. And so the reason IMF really looks at this, you can see they're monitoring 1,400 ports, major cargo ports across the globe. They're tracking 120,000 ships at any given time. And what they're able to do is be able to find the relationship between where ships are moving, the containers on those ships, the status of the ports, and then ultimately project these live views to the public to show how are things moving in transit. And so once you kind of created this model, created this visualization, created the connections between the ships and the ports, that handoff, that crucial handoff that Dan talks about, now I would take it's beyond the efficiencies. It now takes the greater efficiencies gained, and it's allowing that extra time and energy to be spent on how to get more gain, how to get more benefit, how to get higher throughput, put more business through the port. Once you've kind of eased congestion, how to be able to mitigate and move around disaster or disruption when it occurs so that you can continue this moving network, right, is more fluid. So that's the IMF Portwatch. And the next story is BNSF. Well, that's a very land-based, kind of infrastructure-based, asset network. You could see their statistics here. They run the 724 Operations Center. This is their Operations Center, subterranean in Fort Worth, Texas. But what's interesting about BNSF, you say, well, that's interesting to know where the engine is, and then the engine is in correlation to the track. But every crossing area is a security risk. Every container on every train needs to be known where's its point of origin and where's its point of destination. And so it's not tracking train to track, it's tracking all those pieces that we talked about. Where is safety, staff, where are operations, where are logistics centers now versus, kind of a cargo center. And then when you add to it, where is incident weather coming, potentially tornado, hurricane, flooding that could compromise their network? Where are their bridges structurally at risk? And now they're putting that all in one visualization, one decision support system that is helping them on a day-to-day basis, but also helping them understand in 30, 60, 90 days and beyond what capital and what infrastructure weaknesses they can predict to be happening across their network. How much throughput can they put in their network? Can they start contracting a 600-mile run to a 300-mile run? So really has helped transform BNSF into now more of a technology-driven infrastructure than a rail organization.
That was great, Cindy. Thank you. And I'm going to ask each of you this, when you think about, as you describe it, a time and space network, right? And everything in space is measured by longitude, latitude on the Earth, right? Then you have a lot of government agencies that are out there saying, you got to standardize the data, you got to standardize the data. Now, when you're talking thousands of different systems and even versions of the same system that might have different data definitions, doesn't it seem like that's the approach to take to really optimize versus trying to force companies over who knows how long it could take to get to a data standard? Well, what's your perspective on that?
Agreed. And I think that's standards and whose standard is going to win over time. I would say that's a great point, Dan, because that's usually up front, the normalization that has to happen with any organization because they have their multiple systems. I think working and leveraging location, which is already probably one of the world's longest standards, right? As you mentioned, the lat long of any location, that allows this normalization to come into play with these different systems. And the goal in a lot of the work that we've done with these types of organizations is not to move them off of any one thing. We're not trying to move off ERP or CRMs or TMSs. It's really about leveraging this as a unifying layer, using the location as a unifier layer so the systems can exchange and share information. It's not to move off those systems. So that would be my perspective, is that those data models inside those systems don't change. We just extracted the data in the context of location that allows them to all come together.
Yeah, thank you for that. So Jack, as we think about UPS, right, we might think that this is new technology, hasn't been done before, unproven. Geospatial hasn't really had a good footprint in the logistics industry, but you're going to tell us different, right, from your experience at UPS.
So this is 100% not theoretical. I lived it, and I know I'm biased because this is what I was responsible for. But using geospatial data, time-space networks, and appropriate frontline tools, we can make dramatic impact to our operations, and I'd like to talk about that. I want to talk about a little understanding, though, as to how to drive this new race car we're talking about building. And it really depends on decisions. That's the most important thing for us to think about. We want to take data, turn that data into insight, and have that insight drive better decisions. If you can go to the next slide, Dan. Without better decisions, we're really talking about insight that's trivia. We want to impact our operations. Dan, you showed a slide similar to this. This is my favorite one. It comes from IBM. Remember their Smart Planet initiative in around 2010. This talks about decision making and using data for making decisions. So look at the lower left-hand corner. It says you can have a decision that's based on descriptive analytics. And descriptive analytics says what's happened or what's already happened. There's insight there. Above that is diagnostic analytics. That analytics says, why did that happen? And to the right of that is predictive analytics. It says what's going to happen if we continue down our path. Above that is prescriptive analytics. What do I do? So the continuum of analytics moves from what's happened, why did it happen, what's going to happen, what should I do? The most important part of this chart is that as we move through this continuum, our business benefits grow and they will grow significantly. So that raises the question, where is our vision? Is our vision as logistics leaders to stop at visualization and visibility, or is it to move to prediction and prescription? Notice that descriptive and diagnostic analytics, which has the least benefit, although valuable, of course that's least valuable because we're looking to the past and present. To get the largest gain, we need to look forward. We need to be predicting, we need to be planning, we need to be looking at different ways to operate. By the way, this is why Brian will also often say that he's looking for something that's beyond visibility, because we know beyond visibility is where the largest gains exist. Now, it's a couple of things that are important to note. One is from firsthand experience. In order to get to prescription, the data needed there is different than the data you need to describe. So if we're just looking to describe, our data can be rows and columns like an Excel spreadsheet. But if we want to start predicting and prescribing, our data should model our business. And the business is a network. And that's why GIS is perfect for modeling our network, because by definition, GIS is a network. And we need data that matches the decisions we're trying to make. One time I presented this chart, which I've done to all the senior leaders at UPS, to the president of US operations. And he got it. The light bulb went off. And he said to me, diagnostic and descriptive analytics, he said, that's like doing an autopsy. My operation's already dead. I want to look forward and I want to make decisions for the future, I want you to build us systems that let me plan and let me optimize. We built tools that did description, diagnostic analytics, and predictive analytics. And those suite of tools reduced about 85 million miles driven a year. We weren't done because we wanted to layer on top of that prescriptive tools. Just like this model says, we reduced an additional 150 million miles driven a year. So 235 miles reduced annually. That's over 20 million gallons of fuel not being purchased, 235 metric tons of CO2 not going to the atmosphere. I know we care about sustainability, but the greenest mile is the mile we don't drive. So I've lived this, I've seen the gains by putting in the type of technologies that Cindy and Brian will talk about. Let me show you what this looks like graphically. So this is what I presented to the CEO and his staff after our first year of testing this new way of looking at things. There's time across the horizontal axis. The black line is a performance metric of UPS as a whole. And this is after we had already reduced 85 million miles driven a year. And honestly, the thought was maybe we're as good as we're ever going to get. The green line are the results of the test sites that we went to. That covers about 1,500 drivers across geographies, across operating types. And you could see the results are pretty stable. The sites work together until we get to deployment, which is that vertical line. And we dramatically change. By using the tools that Cindy talked about and Brian will, we dramatically improved. Go to the next slide, Dan. And the way you do it is we go from data to information to knowledge, but really we want to layer wisdom on top of that so that a new planner, a new driver, a new manager is performing as well as a seasoned one. And that's what happens with digital transformation.
So Bill, my question for you, with the team talking about geographic information systems and how the ESP team is working with you to deploy this technology. Talk to the audience here about some of the benefits that you see A1 can get from using this type of technology.
So from an ESP perspective, the team has been fantastic to work with and has stepped up to the challenges that I've put out there. And first of all, I would say my intent and my drive was to have a single source of truth. So when you look at all of the developments with technology, whether it's your transportation management system, any systems that you have running analytics, Motive, Samsara for driver tracking and safety, it was tasked on the team to be able to navigate through all of these different systems. So go into Samsara or Motive to see what's happening with driver productivity, use your safety resources to review that. Then toggle back into the TMS to dispatch and to look at work orders and how workflow is coming through. So the first task with ESP was to give us a single source of truth and a platform, which we've now been able to do, and we've fully integrated all of our operating systems. And that's not only on the trucking side, that's on the warehousing side, that's on our container yard management side. So I have a single source that I can discuss with the team and that the managers can review and essentially move towards an exception management process and not managing issues after they occur. We have the ability to forecast and find pinch points. So that was the first step. The second step, as we've developed and transitioned along with the dispatch and having the visibility all integrated into one visibility platform is now, from a driver productivity standpoint and from an efficiency standpoint, it's right there in the team's face. So they have the ability to shift drivers as needed, all using the ESP platform and what we've integrated with. So for me, historically, and going back, 30 years here in logistics, is one, having the visibility in a single dashboard, but two, being able to action that data. So data is great, but data is only as good as how you've used it. And I think, as everybody knows on this call, bad data in can relate to bad data going out and poor decision making. So ESP and that integration has really been able to filter through and improve the visibility and operational information.
Just by chance, this chart was up here, but if you look at the yellow circles, that means that that truck, those are all individual trucks in those circles, that truck is idling, right? And if it's a gray circle with a square in it, that means that tractor is off. So would you agree that most of the vision for future efficiency is probably in and out of the port complexes, right? That's a lot of gray and a lot of yellow in there that people are either in queues leading up to the terminal gates or within the terminal waiting for some service like a chassis or a container. Is that fair?
Yeah, I mean, from our standpoint, I would say the biggest efficiency pickup is absolutely navigating in the port complex. I think a lot of the data that we reviewed today is great because it has geofencing, but the problem is those are static geofences. So with the platform, we've been able to have a very nimble geofencing system that can pick up truck queues based off of how the trucks are idling, right, or not showing movement, which then really gives you visibility to the reality of what the wait time is, right? And the MTO perspective from pedestal to pedestal, and then we've got some of the tracking mechanisms that do use geofencing. But when truck traffic's backed up onto the highway and it's outside of that geofence area, one, it's bad, but two, how bad is it? Because you don't have visibility at that standpoint. So we've absolutely been able to leverage the information and then be able to reallocate truck power to drive a higher efficiency and productivity level.
Yeah, got it. So Brian, my question to you is, what is machine learning and AI? How does that play into this? But also speak a little bit to the dynamic aspects of the geofencing that ESP has within its system.
The key to what we do, guys, it does come down to location, and I have to stress that to everyone. My history has been building software packages like what you see we're doing in supply chain with Bill and other customers in a number of different business areas. And I want you to understand that, because this technology might be new to the supply chain space in some ways, but it's been around for 20 plus years. So it is definitely proven, and the methods and technology, the algorithms that we use have been proven as well through our own testing, as well as testing at Esri. So when we apply things like machine learning and AI, first of all, it's not necessarily a silver bullet to anything. And in order to really take advantage of machine learning, you really have to establish those baseline KPIs. And that's one of the things Jack spoke about, was kind of that, this is what's happening, or this is what's about to happen. When we can understand those things, and we can understand how that data kind of moves together from an after action perspective, what that gives us the opportunity to do is understand how to build models that can attach data to each other to provide you more information. Great example is what Dan has up here on the screen. This is done through millions and millions and millions and millions of historical data points in Southern California, plus real-time trucking data. And what that gives us the ability to do is come in here and predict certain aspects of terminals or wait times or turn times within a particular terminal. And that's what this is showing you here. This is looking at what's currently going on, plus through history and machine learning, it's projecting out what should be going on. And you see this as the blue being kind of the predicted turnaround time, the red being the upper echelon of that, and the green being the lower echelon of that. We've discovered that just with the data we currently have, we're somewhere in the neighborhood of 3 to 7 minutes off. Of course, one of the reasons why we're working with that HTA is to consume. Hopefully, some of you that are listening today would be willing to provide some data to us so that we can make these turn times better. But what's most important is this dynamic concept that Bill had mentioned. If you look at this screen down below, you see the purple, that's the primary area of the terminal. The red is the entranceways to all the different terminals or yards. That's the differentiator between the purple and the green here with what you see. So what we do is we actually can define these based on your company, and what you have as your geofences, right? Because you're going to have geofences for Penske repairing, or where you're taking your vehicles to be repaired. But we can also actually use this in a dynamic mechanism. And what I mean by that is that we can actually expand these entranceways out based on machine learning algorithms that can sense when trucks are actually backing up beyond this particular endpoint of what's traditionally seen as the end, or the end of the wait area for this Maersk terminal. These things work not just in that scenario, but they're also dynamic enough to start to understand where your assets are going, maybe outside of a typical place, or maybe an expansion of a yard, or an expansion of a terminal. So these dynamic geofences work in multiple ways. And what's cool about that is, as they are dynamic, they can still be used in all of our analytical processes. So that polygon grows in the system, we can still analyze data against that growing or that shrinking polygon. So it becomes a little bit more intuitive for our users. So there's a lot of different things that can take place in machine learning and digital twins. What we have to do is we have to understand what KPIs we're going after, and then we have to understand that data. We have to set up that data, and then we build the algorithms to be able to predict or provide suggestions to the end users on what to do with the data that's coming in, i.e. actionable intelligence or actionable information for you as the end user. By moving down this path, though, we do enable you to do a lot more from a digital twin perspective. And in order for me to kind of go into digital twins, I'm going to ask you to step back a little bit to like the early 2000s, when cell phones became very popular, and when the iPhone hit the market. Suddenly that changed computing as a whole for not just the supply chain space, but pretty much everything. We all have what's known as an edge computer in our hands these days, and those edge computers can send location and those types of things, i.e. that cell phone is what's called an IoT device. And once people start to adopt different IoT devices, EDIs in trucks, or GPS units in trucks, or GPS units attached to chassis or containers or whatever, right? What our system allows you to do is use that data right away. Because of the way we architect our system, and because we look at location, we can actually plug those IoT devices directly into our system and immediately start to show value through either a visualization platform, so I can see it here on the map, or I can also start plugging those IoT devices into our machine learning model so we can get more intelligent information out of the other end of it. So I kind of very water hosey coming at you, but from a high level, that's typically our process. One of the other things I'll say is that when this platform started, it was 10 years ago for supply chain and aviation, just as an FYI. And one of the things that we've done is we've focused on understanding what the processes are of our customers. One of the things our company believes in is not messing with processes, but taking the technology and making those processes easy. And so what you're seeing here is you're seeing a lot of configuration to the workflows that different customers want, with a very, very solid back end that's designed for ingesting real-time data and analyzing that data. But what we want to do is we want to focus on your workflows. We want to make you better so that you can serve the BCO better. And that's where our focus is, on making operations smoother.
So we talked previously about how for Bill's A1 group, you're bringing 4 to 5 different systems on the trucking side together to be able to monitor the fleet better. That's a great example of optimizing within a node of supply chain. Talk a little bit more about how you're now integrating the yard and the pass off between 2 different modes, right? From trucking to yard management. with some of the work that you're doing today?
Like the first thing I'll say about what Dan just said is that one of the things we did when we walked in with Bill is we said, okay, tell us what you currently have. You know, how are you operating in your yard? How are you operating with your telematics? How are you operating here? How are you operating there, right? And what we worked on was we worked on how to communicate all those data sources together. Okay, that was kind of the first step. So you know, as we kind of took the next step and started working with Bill's team at the yard, we saw some inefficiencies is really what it comes down to. And because we have the ability now to understand, in some cases, in most cases actually, who's coming to that yard, one of the things that we can do is we can really streamline that process. So Bill's team will be introduced to QR coding and actual license plate scanning upon entry of their container yard here in the next few months. That is designed to streamline that process. And we're actually taking technology that we have and kind of reconfiguring it to enable folks on that yard to drive through the yard with cameras and just confirm the location of where those containers are. We run it through cameras, we run it through a process, machine learning process that reads all the images and then can actually attach the location and the actual container ID to that location. And then it can go back to the yard management system and attach all the additional attribute to it. So that's kind of the process that we're looking at now. Again, trying not to necessarily eliminate anything, but trying to make this yard more efficient. Bill, do you want to add anything?
Yeah, I mean, I would just add, I don't think it's just the yard efficiency, but it starts at the gate and then when the driver's arriving to the gate, right? So being able to pre-lodge that information, knowing the driver, and this goes back to what I had mentioned before about a full enterprise integration. So when you talk about the driver leaving the port, having visibility and access and all of that information in what I would just call a hub, then you can pre-lodge gate information, you can have a speed gate, you can enter that already into the yard system. The yard knows where that driver's going to park. So it really speeds up the process and improves the overall driver productivity.
And Bill, I was going to ask you a question on, you know, some of the regulations that have been coming out for environmental impact. It seems like some of this technology could be a useful tool in solving you know, I guess compliance and measurement, right?
Yeah, correct. Well, first of all, we've been able to automate the majority of the requests that have come in. So, I mean, I don't know about the rest of the team here from an HTA perspective, but the customer requests that we get from a compliance standpoint on the data for where, not so much for AB5, but currently for where compliance, you know, had the team essentially compiling a bunch of different data points into spreadsheets and then sending that off. Now we have the ability and have had the ability to automate these reports and just have them auto sent to the customer based off of how they want to receive it, what format, and then the regularity as to how often they want to receive it. So it's helped from an administrative burden standpoint for sure.
So Jack, you found, from what I've heard, change management is critical to making sure that the drivers adopt the suggestions that the system's providing and to realize the benefits you mentioned earlier. How do you see change management in the whole process of, I guess, connecting an industry much broader than just a company?
Sure. Let's talk about pillars, right? We want good data. Bill said, you know, a single version of truth. Cindy said a digital twin. So we need to synchronize the virtual and the physical. We want tools like Brian mentioned, and then we want advanced analytics. All those things come together and that could be great. But the best platform, the best algorithms, the best analytics, the best tools unused are worth nothing. And we're doing this to get an ROI. So the fourth pillar is change management. And that's getting people to change how they operate and use the tools as their way of operating. What I used to do is I used to listen to what people talked about in the morning. And if they talk about in the morning the same things they did before we put the systems in, I was down the path of becoming a flavor of the month. They were waiting for me to go away and they were going to go back to their old methods. So we need to have lasting change, and we need to change what people talk about. Honestly, I found the best way to do that through measurement. What I used to do is come up with some number of metrics that I thought were important, somewhere between 5 and 10. And I'd measure every operation, every supervisor on how well they were doing in these 10 metrics. And I made as many of them as I could leading metrics, like, is your data accurate? Are you following a plan? Are you reducing idle time, let's say, whatever it is. And I'd rate everybody against that. And when you have change management and leadership at the top, asking those questions and communicating and asking over and over and over again, conversations change, and the lagging indicator of business savings happens. And that's the need for change management. And the best way to do it is by changing conversations. When we do this, the operations end up owning it. The tools, the methods, the procedures, and the job all become the same thing. And we end up with an agile, efficient, and customer-focused operation. And I don't think you can do it without change management. And by the way, Dan, Gartner just came out with a survey that said 76% of projects within supply chain fail. And the largest reason was not having change management. So that's got to become part of what we think about day one.
Yeah, and I suppose when you think about that broader than a company and into an industry, it's really giving companies an assurance that while they are contributing data for the good of the whole, that it will be anonymized when it's shared out, when it's providing analytics for better handoff and better flow, right? I think there needs to be sort of the handshake belief that that data won't be shared with competitors or other folks that they don't want to necessarily have visibility into it with. Yeah.
I think one thing that we're talking about, this concept of the like the digital twin, the single view, and getting predictive and getting, you know, AI models, machine learning. Once there is this concept of a net, let's say a catch net, that is in place, right? That everyone starts to see that dashboard like Brian presented, and that adoption, as Jack had talked about, it starts to be so intuitive as people look. Once they can see it, they want to see it again, and they want to see it again. And as the data collection continues to build, and that modeling and everything begins to kind of reveal itself, it's almost pervasive across the enterprise. And I'm not saying it automates change management, Jack, but it makes it easier to accept, right? Because people are seeing, I've seen this, they just accept it now as a default. And I hate this analogy, and I'm going to use it anyway. We all expect no more than a 2-day delivery now for anything, right? There was a shift over time that made available 2-day delivery, or, you know, 1 hour with DoorDash. It moved everybody's measuring stick. You talked about KPIs, Jack, and what's everybody measuring. I think it just pervasively starts to move the expectation forward. And so that's what we're hoping as a group to do for those efficiencies, but also to get the gains. So I'll stop there.
Thank you, Cindy. So we got 2 questions. So one's for Brian. Why do people in vehicles with cameras, why use to confirm container information in the yard versus using more efficient methods like drones?
You could do either. It doesn't make a difference. If you have the drones, perfect, right? You can do the same process. From our perspective, it's just an image recognition process that we built. The reason why we look at either cell phones or cameras on, you know, golf carts or something like that is just a cost to entry, right? The drones are going to be a little bit more expensive, but anything that's taking a video, you know, I mentioned the idea of using the infrastructure that you currently have, you know, and we were on a call previous to this where somebody asked about streaming video from the yard. Can you pull the data from that? Which we can. So the way to collect the data The image data doesn't make a difference. It's really about the analytic in the back that's going to be able to extract that information out.
Yeah, and to the person that asked that question, interestingly enough, you guys probably do recognize this, as it has a whole bunch of names in history: the Poli Yard, the Cal Cartage Yard. This was drone imagery, yeah. And so we did fly a drone over it. We recognize that there is quite an ability to use drones to identify the containers from the top, and that might be the best way to do it. You can pre-program those drones to do it also. So I guess as a recap, I hope the folks on this call got a decent education on GIS. I really think it's almost like a hidden opportunity for a lot of companies. But there's a massive application to logistics and taking that time and space approach as a great unifier of data, and then using what we call data layers to give the context of the environment that those assets are moving through, right? And understanding the interactions of those assets with the machine learning AI capabilities. So, you know, some of this is here today, right? You saw some of the stuff that Brian put up. That's here today. Everybody's now with LLM and a lot of talk about AI, building out learning models. ESP is building a learning model specifically to address supply chain issues, but it takes time. And it's over a period of time that they learn, and they take history and current information and merge that together with environmental impacts like geopolitical risk and weather and traffic, like we've talked about, to then really get smart. And then as you roll into the future and you get into peak seasons, you have a toolkit to be able to help you be much more efficient. But it will require cooperation across the industry, right? When it comes back to sharing data, there's going to have to be more open attitude towards doing that in order to see these benefits come to fruition. So I think that's about all we have today. Again, I want to thank everybody for coming in. I want to thank the HTA for allowing us to present.